Many people think that cache works like this. The program has written a file, it stored in the cache. It has written another one, it also stored, as long as memory allows. But actually, it's not. Let's take a look at the information provided by the task manager. This is all RAM in use. This is occupied by programs, available, free and cache together, committed, size of swap file and how much it is used. We will talk about the virtual memory in other videos. Cached is a file cache, what we are going to look at it in this video. Paged pool. Memory occupied by drivers that can be unloaded to the paging file. Non-paged pool. Memory occupied by drivers that cannot be swapped out to the paging file. Windows 11 has a SysMain service, the old name prefetch, which keeps track of which files are in use at that time. For example, if you launch the browser every morning at 8 am, it will preload the files needed to launch into the cache at 7. To see its status, you can enter the get-mmagent command in the PowerShell. So that it does not affect our experiment, we will disable it by going to the services. Let's check the status again. Now it's disabled. Now let's see how the file cache works in practice. I wrote a small experiment program what writes random data to the file. This is important because NTFS does not write a file to disk that is all zeros. It's feature of NTFS. Under the hood is actually a whole transactional database. Let's write a file A with a size of 1 GB. We see that the size of the write cache has increased. This is expected. The program told us that the recording was completed in 9 seconds, but in fact the recording is still in progress. Now we read the just write in file A. This took 0 seconds. This is expected, since the file is in the cache. Now let's write file B. All the same, recording took 10 seconds. Now we read the just write in file B. This took 0 seconds. So far everything is going as many expect. But now look, we have more than 2 GB of available memory and both files should fit in the cache. Let's read file A again. And here we see what instant reading did not happen. But instead the file is read from the disk in 6 seconds. Why it's happened? The answer to this question will be provided by Rusinovich excellent program. Mapped files is the cache. Here we see our files A and B and how much they occupy in the cache space, although we actually have a size of exactly 1 GB. This is all because only parts of these files are in the cache. Each part of the file has its own priority, which is changed by the cache logic. In addition to our 2 files, there are hundreds of other files that also have fairly high priority. And here we see what the cache logic is much more complicated. And this is good because reading small files costs the system more time due to overhead. This is such work of the cache increases the responsiveness of the system dramatically and makes using the OS more enjoyable.